Here's your third dose of balancing equations. This time we're given a description of a chemical reaction. From that description, we need to figure out the reactants, the products, the balanced equation, and we're also going to add the phase symbols. Number 1 tells me that solid mercury 2 oxide is heated and decomposes to produce elemental mercury and oxygen. Okay, so look for some key words here. I'm starting off with solid mercury 2 oxide. So mercury is +2, oxygen is -2. It's heated and decomposes, which just means it breaks apart to produce. So here come my products. Elemental mercury, which is just Hg, not diatomic, and oxygen gas. Oxygen is diatomic. There, it's that easy. We just read through the description and look for keywords like something is produced, something reacts with something else. And then we can usually figure out the reactants and the products. We balance. I need 2 oxygen, and now I need 2 mercury. And the last thing I do is put the phases in. They help me out a little bit. Solid mercury oxide. You might remember that there are 2 elements that naturally occur as liquids, mercury and bromine. And hopefully we would know that oxygen is a gas. Done. Well, that's not so bad. When we eventually go to the lab, we're going to read through the procedure and try to figure out the balanced equations. It'll be very similar to something like this. Number 2, zinc metal is added to a solution of sulfuric acid. So here are my reactants. Zinc added to a solution of sulfuric acid. And they tell me the formula, H2SO4. It's kind of like hydrogen sulfate, where the hydrogen is +1 and the sulfate is -2. A solution of zinc 2 sulfate is formed along with bubbles of hydrogen gas. So here come my products. The zinc +2 sulfate -2 and bubbles of hydrogen gas, which hydrogen gas is diatomic. So the first time I read it through, I don't worry so much about the phase symbols. We'll get that eventually. Now I just want to know the reactants and products. We balance. Zinc, 2 hydrogen, and a sulfate, and what do you know? It's already balanced. So now I can put my phases in. Zinc metal, most metals are solids, just not mercury. The sulfuric acid is in solution, which means aqueous. I form a solution of zinc 2 sulfate and bubbles of hydrogen gas. Well, there. I think these are almost kind of fun, actually. It's even more fun to go in the lab and run the reactions, and then we can observe the properties of the 2 products. Number 3. Solid calcium oxide reacts with water, producing a solution of calcium hydroxide. All right. So my calcium oxide, calcium is +2, oxygen's -2, reacting with water to produce a solution of calcium hydroxide. Calcium hydroxide. So again, it'll be handy to have that polyatomic list nearby, especially when writing all these formulas. I will need 2 groups of hydroxide. The whole group is -1. Calcium, calcium. Could it be 2 oxygen and 2 hydrogen on both sides? Lucky day. It's balanced again. Then I put in my phase symbols. Solid calcium oxide reacts with water. Unless we're told otherwise, water's probably a liquid. But then we form a solution of calcium hydroxide. Calcium hydroxide is normally a solid, but in the presence of water, it will dissolve. Done. Not so bad, huh? I think the more you practice, you'll get real familiar with the way that they're worded, and you'll see some common patterns. Now, I don't love number 4, like the way that it's worded I think is kind of confusing. In the reaction of solid manganese 4 oxide and aqueous hydrogen chloride, then I almost wish it was like ... Chlorine gas, water, and aqueous manganese 2 chloride are all formed as products. Ah, okay. So I really have 2 reactants. My reactants are the solid manganese 4 oxide. Manganese is +4. Oxide -2. I'll need 2. Aqueous hydrogen chloride. Hydrogen chloride +1 -1. And now here come the products. Chlorine gas, diatomic, water, H2O, and manganese 2 chloride. Manganese +2 chloride -1. I'm going to need 2 chlorine. All right. Let's balance this thing. Manganese, manganese, 1 on each side. Here's 2 oxygen. I'm going to want 2. So let's go double the water. Now that's going to give me 4 hydrogen. 4 hydrogen. And look at this. 2 chlorine and 2 more. Done. That wasn't so bad. Awesome. Last thing I do is the phase symbols. And again, they'll give you some help. Solid manganese 4 oxide, aqueous hydrogen chloride, chlorine gas is formed, water is probably a liquid unless told otherwise, and aqueous manganese 2 chloride, a solution. Done. Awesome. So again, the more we practice, the more we'll get used to some of the way that these are worded, and we'll find some common trends. Like number 5, this is a very common type of reaction. Solutions of lead 2 nitrate and potassium chromate are combined. Those are my reactants. I got a lot of polyatomics going on here. Lead is +2. I'm going to look up nitrate. NO3 -1. I'm going to need 2 nitrate groups. Plus potassium chromate. Potassium chromate. The polyatomic chromate is CrO4 -2. Potassium is +1. I'm going to need 2 of them. It's not a polyatomic we use very often, but you can look it up on the chart. The ATE ending kind of hints that it'll be a polyatomic. I should form a precipitate of lead 2 chromate. So here's where it's kind of nice to have the charges written in. Lead +2, chromate was CrO4, and the charge was -2. And that's neutral. And a solution of potassium nitrate. The potassium was +1, nitrate -1. All right, that's neutral too. So you look up the charges once, use them twice. Now with all these polyatomics, they stay the same on both sides, so I can balance them as groups. So I can say 1 lead, 1 lead. This is 2 groups of nitrate, I need 2 groups of nitrate. Now that gives me 2 potassium, which I want anyways. Chromate, chromate, it's done. If you get these formulas written correctly, I promise the balancing is going to be the quick and easy part. Last thing I do is put the phases in. These are solutions of lead nitrate and potassium chromate. A precipitate of lead chromate is formed. That's a solid formed from a reaction of 2 solutions. And my potassium nitrate is also a solution. So if I were really to run this reaction, I should get some kind of a cloudy solid, which then if I wanted to, which is what we'll do in the lab, we'll filter this. I'll collect the solid on my filter paper, and the solution that drips through, that should be my potassium nitrate solution. Awesome. Piece of cake. Let's look at 6 and 7. Baking soda is solid sodium bicarbonate. I wanted to mention this one because bicarbonate is a polyatomic. It's hydrogen carbonate. And the whole thing has a charge of -1. Sodium is +1. So it is neutral. Sometimes people will try to do like 2 carbonates. They'll think that bi should mean 2. No, it's like hydrogen carbonate. If you look it up on your polyatomic sheet, it's listed there, bicarbonate. It decomposes in the presence of heat to produce. So decompose just means it breaks apart. We're going to make some solid sodium carbonate. Now carbonate is just CO3 minus 2 plus 1 on my sodium. So I do need 2. Check that polyatomic chart whenever it ends in ATE. Water vapor and carbon dioxide gas. All right. I need 2 sodium on both sides. Now this is going to double everything. So I have 2 hydrogen, which I have. It's going to give me 2 carbon, 1 carbon, 2 carbons. And look at this. 6 oxygen, 3, 4, 5, 6. It's done. Yes. Last thing we do, phase symbols. We have a solid. It decomposes to produce another solid, sodium carbonate. Water vapor, now I would put this in as a gas, and the carbon dioxide is a gas. There. Not so bad. The last one says that phosphoric acid, or aqueous hydrogen phosphate, is formed from the reaction of diphosphorus pentoxide and water. So this phosphoric acid, that's my product. The arrow should just always point toward my product. Aqueous hydrogen phosphate. Hydrogen plus 1 and phosphate. PO4 minus 3. I need 3 of those. Now, I don't know why, but people always turn into boneheads now when they see this diphosphorus pentoxide. Could it really be so easy? Yeah, it's covalent. So they share electrons, and we don't need charges. We don't need a periodic table. We just need those prefixes. And water. Done. All right. Let's see here. 2 phosphorus. So I'll probably want 2 phosphorus. I got to go all the way out in front. Now that gives me 6 hydrogen. Oh boy. Okay, so 3 times 2 would be 6. I have the 2 phosphorus. 8 oxygen. Here's 3 and 5 for 8. Balanced. These are almost kind of fun. You're probably not going to admit it, but you're enjoying this. The phosphoric acid is aqueous hydrogen phosphate. It's formed from the reaction of, so here are my reactants, diphosphorus pentoxide gas and water. Which again, if we're not told otherwise, we'll use water as a liquid. Pretty awesome, huh? So again, I would suggest now try the last few and then come back to the next video and we'll look at the last couple here where we're writing the equations for reactants and products from a description of the chemical reaction. After we balance it, the last step would be to add the phase symbols.